On 18, we have all these gases. Notice none of them are liquids or solids, and they will all figure into the K math. We're given atmospheric pressures for all of them. This is a bit of a distractor here because we're already given the atmospheres. So we don't need to divide by 2 liters. That would be true only if we had moles and we needed molarity. The atmospheres already compensate for the size of the container. So on A, we're asked to write the equilibrium constant expression. And so it's just this with just the pressures in there. And we already know that the value is 15. So is this at equilibrium? Well, it is if Q value using the current values is the same as K. So let's take them all and do products over reactants to the power of the number in front. And so these are all to the first power, it turns out. So we'll take the products over the reactants and they're all to the first power. Um, and we get 8, which is clearly not as big as 15, which means that the numerator in our fraction is not big enough, which means the products are not big enough pressures. So this reaction will proceed to the right until such a time as the numerator, to the powers of the number in front, the first power, and so forth, divided by the denominator equals 15. 15. So this is going to increase to the right, shift to the right, until such time as Q equals K. What's the value for Kc? Because of course this was Kp, that was Qp, and that's Kp. So you flip to the formula part of the test booklet if you don't remember, and it's not that complicated a formula. Do make sure to find the right R. Again, it doesn't have joules in it, and it doesn't have torr. So we're looking for the one with atmospheres unit in it. It's 0.0821 as I recall. And the trick here is the delta N. Delta N is the change in gas molecules from left to right. So we had 2 gas molecules becoming 2 gas molecules, which means that the change in gas molecules is 0. So all this is to the 0 power, which means it's 1, which means effectively, mathematically, we can cross it out because anything over 1 doesn't change. So the Kc is equal to the Kp. There we go. And so Kc is also 15. If the temperature was raised, what would happen to the value of K? Well, if the temperature is raised, this would increase the power of the right side. And by Le Chatelier's principle, the system will try to relieve the stress. It will shift toward the weak side. If we give it heat, increase the temperature, the right side is the strong side, everything will shift to the weak side, toward the left side. Now, that means that K went down. The forward reaction is less preferred than before. So the K value, of course, evaluates the forward direction. So the K will reduce if it's being driven left. The reaction will shift left or less to the right away from the heat, so K must have decreased.